Dois. Muito bem. Okay. Hello, everyone. Nice to meet you all. My name is Celso Martinho. Well, first of all, I'd like to congratulate Philip and the rest of the group for doing this demo party in Almada. And thank you for inviting me. I think doing these events is really important, and I know you've been struggling to organize them in many ways. So thank you for putting this up, and thank you for inviting me. It's a real pleasure to be here today. I'm not a demo scener per definition. I've done a couple of bouncing balls in assembly in my Commodore 64 back in the 80s, but I don't think I can call myself a demo scener, not professionally like you. But I do enjoy retro computing quite a lot for many reasons, but mostly because I was lucky enough to be part of two revolutions in my lifetime. One was the computer revolution back in the 80s, early 80s with the 8-bit computers. Many of those you can see in the corner over there. And then a few decades later, I was also lucky to be part of the internet revolution. But getting into computers changed my life. I still remember the first time I saw Timex Sinclair 1000, also known as the ZX81. It was not mine. It was from a friend of our family. I was a kid, but when I saw that computer, I started being I started going to my neighbor's house quite a lot, to the point that he got annoyed about it, and my parents had to buy me a computer for myself. Anyway, so today I lost signal, obviously. Okay. So today I'm going to talk to you about how... So I've been into this, I lived the 80s and the 8-bit computers and later the internet. It's been a long career. I'm now an engineering director in an American company called Cloudflare. But as many have done, I came back to the old computers, and I've been doing a lot of retro computing lately. I know retro computing is all the rage now. Everyone's doing it. There's a couple of reasons why I do it myself. One is because it's a lot of fun. I've always been the kind of person to build stuff, kind of a maker. I've been into electronics as well, so just building stuff in general is a lot of fun for me. But doing that with computers also, it's very educational, and understanding how old computers were built. To the detail of everything, understanding the architecture, how the chips work. Although modern computers have anything to do with the computers of the 80s, there's still a lot of commonalities, and you can learn about modern computing by understanding how the old computers of the 80s were built. So it's also interesting and educational because of that. And so I'd say that, over the last few years, I've been either restoring or rebuilding a lot of those old computers. I have a huge collection at home right now. Can't say that my wife loves my hobby, but it is what it is. I've got, ZX81s, Commodores, several of them, Amigas, Next computers, early Macs, you name it. I probably have one of those in the garage. But one thing I did a few months ago was I decided to build a Commodore 64 from scratch. Well, not exactly from scratch, but I did all the soldering, and after quite a bit of work, I eventually got a working Commodore 64. And I'm going to try to explain to you how I did it. I would like this to be a dialogue, so if you have any questions, instead of waiting until the end, just raise your hand and ask me questions. I would like this to be a dialogue more than me talking to you, if you can. So yeah, I mean, first of all, the Commodore 64 was very special for me because even though I've been around the Sinclairs and the ZX Spectrum, the Commodore 64 was the first computer that gave me that feeling of, whoa, this is really ahead of anything else. This computer can do things that I've never thought it would be possible. I caught the Commodore 64 in a very special place in time where there was already a big community. The games were amazing. There was a lot of support. There was a lot of magazines. And so the whole community around the Commodore 64 was very vibrant, and I was lucky to be part of all of that. So in a sense, it was the single computer that had the most impact in my very early life, and it kind of led me to stick with computers and then be part of the internet revolution later in my career. So there's a very special place in my heart for the Commodore 64 specifically. And that's why I decided to build one after all these years. I had a few requirements for building a Commodore 64. One, I wanted to do something beautiful from an aesthetic point of view. I wanted it to last. So I was trying to build something that I could keep and make sure that it lasts for a few years or more. And I wanted to stick with the original chips, but also do a few modifications and some modernizations that I think are reasonable. I don't like emulation. I think that takes the beauty of all old computers. And I'm also borderline. I don't know if I like FPGAs and stuff like that. I know that's not emulation, but it's kind of emulation as well. So I try to avoid that. I try to avoid emulation or FPGAs. But there are a few replacement chips that I put into the Commodore 64, the new Commodore 64. So the first thing I did is I bought a PCB. And funny enough, there's a couple of modern alternative PCBs for the original Commodore 64 out there. And one of the most famous ones is this 60 clone replica. And they actually have like 2 or 3 models of the original C64 boards. And I went with the most classic, which is the AC 250-407 revision C, which was actually one of my Commodore 64s. So this is the long board, one of the first long board Commodore 64s. A lot of bugs in there, but I kept the bugs. A lot of inefficiencies. Later revisions of the Commodore 64's PCBs were simplified in a lot of ways. And eventually they even did a shorter version of the PCB. This is why this is called the long board C64. So I bought a PCB with no components at all. and this was the start of the project. As you can see, the PCB is beautiful. It's a high quality PCB, but it's the same size. The components are on the same place. It's basically a replica of the original Commodore 64 PCBs. And you can compare this modern PCB with the old one. As you can see, despite the old one being rustier and green, it's pretty much the same dimensions, and the components are pretty much in the same place. Okay. And then what I did is I bought a bunch of chips, and this was a mix of was a mix of using some of the chips I had myself, because I already have like 3 or 4 Commodore 64s in my garage. Some of them work, some of them not, but I kind of had enough chips to start. And the ones I didn't have, plus all the other components, resistors, capacitors, diodes, everything else, I just bought a few kits, and I sourced enough components to build the whole thing. The store that I used for this was this store called Retro 8-Bit Shop, and they carry most of the chips you'll need to build a Commodore 64 if you want to. Okay, so let's go over the chips. So, a couple of things. So, 2 of the chips that I had to use from the original Commodore 64s was the CIA chips. The CIA chips, so it's basically the MOS. MOS is also known as MOS, was the company that Commodore acquired to build their own chips. I actually have a MOS t-shirt today to be on theme. And the CIA chips were basically the complex interface adapters. They do things like the I/O port controllers, parallel serial ports. They also have the timers, the internal timers that the computer needs. And they also control things like the disk drives, the keyboard, and the joysticks. So they're pretty important chips for the computer. I had to use the original ones because there are no modern replacements so far. Maybe there are, because they were building this modern FPGA-based replacement. So maybe it's ready, I don't know. It wasn't available when I started, so I just used the original chips. Fun fact, the Commodore Amiga that came out a few years later also uses pretty much the same chips as the Commodore 64. They're slightly improved, but they're actually compatible. You can take an Amiga CIA chip and use it on a Commodore 64 with very few modifications. That just tells you how good they were. Also, a fun fact, I'm sure you know, about how a lot of people are doing these FPGA replacements for old computer chips. It's really amazing from my standpoint, because what a lot of people are doing is they don't have the schematics for the chip. In many cases, they were lost, or they are somehow still embroiled in intellectual property stuff. And people are just doing very creative things, trying to reverse engineer those chips by scanning the chips, by doing, and the only way you have to do reverse engineering of those chips is basically, you know, either try to scan the chips and look how the transistors are connected together, which is almost impossible or very difficult, or you just send inputs to the chip and see what the outputs are. And you have to do that like millions of times. So it's like a trial and error process to reverse engineer these old chips in order to be able to make modern replacements using FPGAs and stuff like that. So it's really, really amazing. What other chips did I use? So the Commodore 64 also has 3 ROMs. I also use the originals for this. So the 3 ROMs are the basic interpreter, ROM number 1. The other one is the kernel. And the other one is the character set. So basically, the Commodore 64 has a chip just for the font, which is interesting, especially today. And funny enough, the different Commodore 64s for different regions had different character sets, ROMs. So, for instance, the Spanish Commodore 64 actually had the accented Spanish characters just for that specific region. And that was the case for other regions as well. You can easily replace these ROMs with burn EEPROMs. If you want to. There's nothing special about that. But I decided to use original chips for my replica. What else? The CPU is the famous March 6510, which, in case you don't know, was also used in a lot of other 8-bit computers of the time. Not just the Commodore 64. Even though Commodore owned March, the factory that did these chips, they were actually used by other manufacturers and other computer companies. And those include things like 8-bit Ataris. The Apple II actually used the 6510. And the BBC Micro. I think there's a BBC Micro over there in the corner. It uses the same CPU as the Commodore 64. And another fun fact, believe it or not, they still manufacture the 6510 today. There are still applications for these kinds of chips. Don't ask me why, but it is what it is. And of course, there's someone trying to reverse engineer the 6510 and doing an FPGA replacement. And there's lots of emulators for the chip, as you probably know. The other very interesting revolutionary chip that made the Commodore 64 very famous was the VIC-2, or the MOS 6569. This was revolutionary because, well, think of this chip as the most amazing NVIDIA card today. But 40 years ago in an 8-bit computer. But it could do things like direct memory access. It had sprites, which most computers at the time didn't have at all. It had high resolution, beautiful colors to go with it. So it was really far ahead in terms of sophistication compared to what other 8-bit computers like the Ataris and the ZX Spectrum were doing at the time. It also had a few problems, but they were mostly advantages overall. I actually used a ceramic VIC-2 chip for my replica. So back in the day, we were not using the insulation of the chip. The very first chips use ceramic, and that's one of the versions I'm using with my replica. And as you can see, it's a beautiful chip. And then we have the RAM chips, standard DRAM chips, 4164 chips. What else can we say? Okay, let's talk about the chips that I replaced with modern alternatives. One of them was the PLA. The PLA for the Commodore 64 is called, it's the Programmable Logic Array. and its function is basically to do bank switching on the Commodore 64. So for those who don't know, the Commodore 64 has more memory than what the CPU can address. Okay? And how is that possible? How can it have more memory than what the 6510 can address? Well, it's possible because of the PLA. And what the PLA does is, according to some register you can set, it bank switches RAM from one place to the other. Okay? And that's how you can share the same addresses for things like the character set, or just run a program in RAM if you want to. So it's one of the beautiful things about the Commodore 64 that made it so powerful, was the fact that it could do something like this. And so the PLA, the reason why I replaced the PLA chip is because it's also one of the first chips to go wrong over time. If there's one problem with your Commodore 64, it's probably the PLA. It's just that. It's one of the first to die. Fortunately, there's a couple of replacements you can use, and I use this, I don't know, you read the number, but it's one of the possible replacements for the PLA. There are others. It's been widely reverse engineered, so people know how to do these replacements. The other replacement I used, and some of you may call this a crime, was I replaced the SID chip. Okay, and for those of you in the demo scene, I'm betting a lot of you know what the SID chip is. It's still today used in a lot of demos, especially the retro computing demo scene. There are still artists doing music for the SID chip. And so the funny thing about the SID chip is that it's a hybrid chip. It contains both analog, electronics, and digital circuitry in the same chip. And what's funny about this is that every chip is different just because it has analog parts inside it. And so there are many stories about the SID chip, but some of the funny ones is different batches of SID productions have different sound, have different bugs as well. But it was a very famous chip, and it's still used today. And it's very expensive. If you try to buy a SID chip on eBay, it can cost you 50, 60, 70 euros just for one chip. And it's going up, by the way. So I basically use this ARM SID replacement. As you can read, it uses an ARM processor to emulate the SID chip. I know, it's a crime. I also have original chips, SID chips that I could use, but I went with the ARM chip. It worked just fine. Okay, assembly the 60 clone. So I had all the components. I had soldering paste, solder. I could start. So the first thing I did is I went to this website. Let me see if it works. Okay, so this is a website called the C64 PCB Locator, where you just select the board revision that you have. So in my case, I think it was this one. And it gives you an interactive application right on the browser. You can actually zoom in this. Oops, nope. Damn it. I made it worse. Let me see. Ah! Seriously. I don't know what I'm doing. Okay, cool. So, yeah. Okay. So you can actually you have all the components in here, and say that I want to know where the, I don't know, one specific resistor is. Let's say this one. It will basically highlight the component in the PCB that corresponds to the component that you selected on the menu. So this is a very useful resource when you're about to solder like a few hundred components on a PCB. And it can actually help debug some situations that you probably find over your work. So if you're going to do this, just bookmark this. And as I said, they have 3 revisions of the Commodore 64 board. So yeah, very useful. So I started with this, and then I just started populating the PCB. So for those familiar with electronics, there are a few rules that you should follow. You should start by soldering the low-profile components, things like the integrated circuits sockets, which I did. As you can see, I'm not very good, but I'm also not very good at soldering. Then I did the resistors, the capacitors, the physical connectors, the voltage regulator, the basic stuff, the crystal. And then finally, I started populating the chips, doing the big capacitors because they have a high profile. I also put a analog modulator in the PCB, which I later removed. So old computers would connect to old television sets, and they would use modulated RF signal. And I just took one of my old analog modulators from an old Commodore 64, and I put it on the modern PCB. But I regretted this, so there's a replacement coming up. Another thing I did is I bought a modern power supply, because the old Commodore 64 power supplies were shit. They were also known as the brick of death. Yes, because they sometimes would just blow up and burn and take your house on fire in some cases. So not a good thing to happen. So I bought a modern replacement, and glad that I did so. The funny thing about the power supply of the Commodore 64 is that it uses 5 volts DC for the chips, most of the chips. But there's one chip that needs 9 volts AC, which is weird. And that chip is basically the SID chip, I think. Yes, the SID chip needs oh, right. So you use 9 volts AC to get 12 volts DC for the SID chip, and you also use the AC line signal to sync up the one of the CIA chips timers requires that. So it's a funny power supply, not very usual. Today, power supplies just have one single DC voltage, but this one had 5 volts DC and 9 volts AC. Anyway, modern alternative, I highly recommend you do this. So the modulator was a bad idea. I eventually took the analog modulator out, and I also put a replacement. One of these nice kits called the Commodore 64 128 S-Video Bypass RF kit. What you get from this is a much more clear composite video signal, but you lose the television RF signal, which I don't need anyway, because I'm just going to use composite video. Okay, so I built the I built a Commodore 64. Then I wanted it to connect to one of the most popular computer monitors of the time, and that is the Commodore 1084X, which I own. Um, I did it. I plugged in the computer, connected to the monitor, and it was not working. Because we don't have a lot of time, I'm just going to fast forward. But I, I basically went months trying to understand what was wrong with the board. I replaced a lot of chips. I read about a lot of electronic circuits about the Commodore 64. I couldn't just find the problem. The video was not in sync. I knew that everything was working. I could see the cursor blinking in the monitor, but the video was just out of sync. And I could just not sync the video for some reason. I put out the project for a few months because I was frustrated. And then one sunny day, I decided to put an old working Commodore 64 side by side with my new board. I took the oscilloscope, I started reading all the signals, comparing them, and eventually I found that it was a freaking timer chip on the VIC-2 circuit that was faulty. And I could swear I had replaced it earlier. Probably I replaced it with another faulty timer chip. Anyway, the third time was a charm. I replaced the chip, and everything started working. And as you can see, I finally had a working Commodore 64, crisp picture, passed all the tests, and voila. So what I'm going to try to do now, and I'm probably going to fail at this, is show you the actual machine working. So disclaimer, I haven't been connecting this to power for a few months now. So this is the beauty. This is one of my old keyboards. It's a transparent case. Funny thing. So there's this guy that found one of the old molds for the plastic cases of the Commodore 64C in America. It was in an auction, and he just saw the mold in the auction. It was a very rusty mold. He took care of everything, and he brought the mold to Europe. Cleaned up the mold, and is now injecting new cases for the Commodore 64s, brand new. So I bought a transparent case for my PCB, and the guy is selling these cases online. Anyone can buy them. Really interesting. So I bought a transparent case, and everything else is inside. You can see the beautiful black PCB in here, keyboard. Let's try to connect this. It's not going to work. I know it. I can feel it. We'll try. Should have probably tried this at home before coming here. But, you know, there's a word for this. It's called salsadas. And I can feel that there's one about to happen. You can feel it too, right? Okay. Power brick is working. That's good. And I've got something here to convert composited video to HDMI. What can I turn off here? Okay, let's try this. Cool. Nothing exploded yet. All right. This is working. And now I need the composite video cable, which I probably should have. Ask me questions. while I... What's that? Oh, but that's emulation. I told you what I think about emulation. Um, I have nothing against emulation, but it's not just the real thing, you know. There's some beauty in preserving the original architecture, and that's why. I mean, uh, okay, fine. Oh, that's the question you should not ask me. It was very expensive. I mean, I can tell you. Let's see. The PCB alone, I think, costs, I don't know, 100 euros, something like that. Then the components, well, assuming you have some of the components, which I had to buy the power supply, I had to buy a few chips, the kit with the resistors, capacitors, and all of that. The physical connectors, you need to buy some of them as well. I'd say this should have cost me like 300, 400 euros, probably. I'm also in a place in life where I can do this. If I wasn't, I could probably spare some. I could probably desolder some of the stuff from the old Commodores and spare some money. The plastic case is really expensive. Also, I didn't have to use this, so yeah. I mean, no one ever said that retro computing was cheap, right? It's actually quite expensive these days. So let's see. Is this the right port? Yes. So composite video here. Let's see if we can get audio as well. Let me plug the HDMI in here. Power supply in here. Are you ready? There's light. Doesn't smell funny. Do you have image? No? Okay, could be something here. No? What's that? Okay, this is good. Wait. No, this is not good. Ah. Ah. Right. No signal. No signal. Ah, cool. Yay. So something isn't. I think. I think one of the ROMs just. Let's try the turn off and turn on strategy. Okay. So the image quality is horrible. Probably because I'm just using composite. I could use S-Video, but whatever. I then have a cartridge here called a backbeat cartridge that basically emulates like a disk drive, and I can just run Commodore 64 code from here. Let's try to use this. Maybe I can get a game going. Does this work? Yes, it works. Cool. So let's try the famous Gianna sisters. Huh. Cool. And I have a joystick with me. And I also have a speaker, because what's the fun of this without some good sit ship music blasting? Okay. So joystick. Did I do something? The same thing on. Yay. Wrong part. Cool. Now you're gonna have to see me play Gianna Sisters. This was like a ripoff of Mario back in the day. They were actually sued and had to remove the game. Anyway, this is it. Everything worked. I hope you enjoyed this little story. I'm now restoring Amiga 1000, Amigas, whatever. Thank you. I have one question. Go ahead, Andre. Yeah. So that there are a few ways of testing things. If you're into electronics, I have some background on that. You can just, follow the circuit, because the funny thing about old computers that stopped being true at some point in time, sadly, is that you have schematics for all of this. So you can actually read the schematics. And if you know something about electronics, you can just take the multimeter or the oscilloscope and, troubleshoot by reading the signals. That's one way to do it. The other easier way of doing it is like having a good working computer side by side, and you just by comparing things, taking chips out and chips in, putting them in one place and the other, you can do a lot of troubleshooting just using this technique. This is actually the most used troubleshooting technique still today, having two versions of the computer, and one is working, one is it's not, and you just keep exchanging chips. The other thing you can do is there's now these modern, relatively cheap chip testers that you can buy. There's actually one from the same brand of this cartridge called Backbit. And you buy one of those, and it's got a little universal socket where you can plug any chip from any 8-bit computer, and you turn it on, and it tests your chip. And it tells you if it's faulty or not. And in some cases, it can actually tell you what's wrong with the chip. And in some cases, you don't even need to take the chip out of the PCB of the computer. You can just test the chip on the board using little clamps that you put on top of the chips. So there are many options today to help you troubleshoot. And there is another thing today that helps a lot, which is called YouTube. So there is a lot of knowledge online in the retro computing scene that you can take advantage of. And it's great times to do this. Yeah. Yeah. That it's a contradiction. I know. I'm guilty for that. But I have the original seed chip there. I just thought it was funny that so this ARM version of the seed chip, It's emulation, but it was so nicely. It was the first emulated SID chip that was very faithful to the original one. And it's even if you look at software emulation for the SID chip, it's never quite the same as the original. And well, you must specify which original because even the original ones are different one from the others. But this ARM chip is pretty good. They also have a stereo version of the SID chip that you can fit into the Commodore 64 that I have, and you get two SID chips in a single chip. And there are actually games and newer demos that can take advantage of that, and you get stereo SID sound. But yeah, I'm not proud of it. Sometimes I take the ARM SID out of the PCB and I put the original one because that's what I should do. Any other questions? So a lot of things can go wrong with analog video in general. I think what's wrong with this is I'm using composite only. I should have used the composite plus the luminance, the S-video signal, which improves image quite a lot. And there's probably something wrong with the VIC-2. By the way, the Commodore 60, one of the VIC-2 is the video chip of the Commodore 64. It's pretty awesome in terms of features, but it's pretty shitty in terms of image quality. It's really, really bad. It's one of the downsides of the VIC-2 chip. And sometimes you need to fine-tune a specific capacitor in the timer circuit to get good image. There are also filters that you can put on top of the chip to avoid getting noise into the video image. So it's not one of the good parts of the Commodore 64, the quality of the video signal. And I think that's what's wrong with it. It was better the last time I turned it on. So, any last question? I need to drink some water. Well, this was a lot of fun. Hope you enjoyed. Thank you so much.